Hello?
Hey, can you hear me?
Hi. Yeah. Welcome to this interview. Um,
Hi,
this is
thank
gonna
you.
be a 40-minute interview. Um, we're gonna divide it by first 5 minutes. You can tell me a bit about yourself. What are you preparing for? Next 30 minutes, I'm gonna give you a task which we're gonna work on. And in the last 5 minutes, we're gonna exchange feedback. I'm gonna tell you how you did. You're gonna tell me how I did. And this is generally the plan. Sounds okay?
Yeah, that sounds good. Yeah. Um, so I am preparing. I don't have anything lined up, but I'm preparing for just interviews. Maybe something if comes up. I'm kind of right now focusing on like data structure and algorithms. I haven't done any system design stuff. So yeah, that's where I'm at.
Mm-hmm.
I have I have about 7 years experience. Um, doing full stack. I do everything, back end, front end, whatever.
Okay.
Yeah.
Um, okay, this sounds nice. I'm gonna give you a task. Let me know if you solve the exact same task so that
Okay.
we can
Yeah. Will
know the questions. Yeah, I'm
do.
gonna
Okay.
put it here in
I
the
changed
editor.
this to Python. Yeah. Can you hear me?
Yeah. Did you see the task or wait? I think that
Uh,
those
oh
comments.
yeah, I see it now.
Yeah,
Yeah. Okay.
there's a lot of
So
noise in the comments. Sorry.
okay, given array of characters and a string. Okay. I'll just create some examples if you.
Hmm.
I think just to confirm. So it would be like input would be A, B, D, uh, E, F, and ABC. So output should be, I'm sorry, output is ABDC. Oh, yeah.
Hmm. Hmm. Yeah,
Did
this is
did
a
I get the
correct-
question?
yeah, this is a correct example. Yeah.
Um. So okay. So would the input have multiple characters like this? Maybe.
Yeah. Let's actually for the base case consider that the character array is gonna be consisted of unique characters, meaning there's gonna be no repetitions.
Oh, okay. No repetitions. Um. Okay. So what I'm going to do basically is um, so if it's ABC, I'll start with like start here and keep hmm. I'm just trying to think. I'm going to like create like a sliding window and move the window. So what happens if the input string is So the answer, I just changed the input in the example. So answer there would be not this. So that would be the answer. Okay.
Hmm?
Uh, okay. Yeah. Sorry, it took me a while to think. Um, so yeah, I will start with input array, input, and keep going forward. So can you see my cursor?
Yeah, yeah, I see it.
Keep going forward. So I would remove a from the. I'll put that in a set. This ABC. If I see it, I'll remove it from the set. I'll keep going to B. Remove B. I don't have D, so I'll do nothing. So I see A, but A matches the first character. Um, First character of the input. So I'll just move the start from 0 to 1.
Yeah.
Um, and
About
go.
so you mentioned that you remove it from the set.
Hmm.
Yeah. So
Yeah.
when you reach A again, how do you know that this is the character we're looking for? If you removed it from the set, or do you keep another set?
Um, how do I know if it's a character we're looking for? Oh, I see what you mean. Uh, it has to be because in the beginning, if it's in the beginning, right? So let's say A was not here and you see A, so this would be an invalid set, right? So ABD, like that won't be a valid set. Like
Mm-hmm.
we shouldn't have been adding A at all in the beginning if it was not there. So
But
that's how I would know.
more meaning of the so when we have ABD and
Hmm.
so you're saying you're doing a sliding window, so you correctly like started from there and
Hmm.
want to move up to A and see if it's there. But since you say you have a set and you would have removed B and A at here,
Hmm.
and you move to A and how do you know that this A is part of the important characters that you're given? Let's name them important characters because they're in the character array, and we're gonna need them to
Hmm.
actually identify
Yeah.
that. So how do we know that A is there if we don't have it in the set anymore to do an operation and check?
Yeah. So yeah, when we start the array, um, if A is not here, right? So the window would not have A at all.
No, I mean I'm saying if we're at the stage where we have this window,
Hmm.
we analyze this window, and because we're already, let's say, I'm gonna put a delimiter. So we're here, and we've removed both the A and the B, which are here. So these two are removed because
Hmm.
I think you said by when you hop over a character, you remove it from the set, right?
Hmm. Correct. Yeah.
Yeah, and we're at this point. We
Hmm.
have B as a substring, a temporary substring, and we move towards the other A. So how do we know that this A is something that is of value
That
to
is
us?
in the. Yeah, I understand. So if A is not here in the first place, and we start the window, right? We
Hmm.
see A. We don't. We don't start it. We don't include it. So it won't. It would never have A in the first place. So that would be the window. Like what the start, like the start pointer would not start from here if A is not here.
Yeah,
The
but
start
I'm
start
saying
would be here
yeah, A would be in the input, but when you hop over A, you said that you remove it from there. So you
from
you
the beginning.
No, from the set. So this is a
Yeah,
set,
I
right?
remove it. Yeah, correct. Yeah.
Yeah. So we need A. We have A in the input. Um,
Mm-hmm.
when we reach A, we remove it from the set, right?
Correct. Yeah, you're right.
So when we encounter another A in the string, we can't really check if this is a character that we're looking for.
No, we can check. Correct. Yeah.
So how can we repurpose that so that we can still check for, I mean, we can still label that we have characters and we have seen this character, as you said. So like you use the remove from set mechanic, but
Mm.
this basically eliminates our ability to check more than once. And if we have something of the kind of AAABC, and we check the first A, we remove it from the set, and we reach here. So the first substring that we're gonna find is this, and to basically like find this, how do we know that we have to remove the A's to actually find the array because we no longer have a set to reference?
Um, so what I was saying is that if your substring, right,
Mhm.
if your current window is this, right, and
Mhm.
you've already removed a B, you
Mhm.
see A here, and the string starts with A, so that automatically implies that A has to be. Like otherwise, why would the string start from A? Does that
Uh,
make sense?
yeah. What if the A is, for instance, over here?
Then you just oh, so you see A, and you see one more A. You keep adding though because you haven't seen C. You have no option but to add the other A. So you just keep going
Yeah.
till you see the C, right?
Mhm.
You cannot do anything. You can only remove from the front. You cannot just remove from the
Yeah.
middle or
Yeah.
anything.
Correct. So okay,
Yeah.
let's go to the point where we've seen it all. So how do we move from actually let's yeah, this is actually a correct output, okay? Yeah. Okay, so let's actually let me just think of a way to test the mechanic you said, like starting with. Um so you're basically checking when you for after you've empty up the set, or you're checking if every new character is like the starting point of the substring, correct?
Correct. Yeah.
Can we do it? Because um, I would be guessing. Um, wait. So say that we have the input, which is, again, let's have ABC, and then we would have, oops, um, then we would have something of the kind of Q, B, Q, A, Q, C, then A, um, and then QB.
Mm.
Okay. How would it handle this?
Oops, sorry. So yeah, same algorithm. So start will be here. Q is not here. I'll say okay, moving forward. So I'll see B. Okay, I'll say okay, B. I saw B. Gone. Keep going. I see A. Gone. Yeah, C. So gone. So that would be the answer.
But yeah,
I
but
mean, oh, yeah, I guess A, B, like, yeah, I can just return that. Like, this could be the answer.
yeah, I mean, yeah, if we have something like this.
Hmm.
Can you look more in the way of actually? instead of using the set as like um, as a true or false kind of well as like as a binary storage, but binary in the way of like it's either there or not there, and it's like if you remove it once you can't get it back. Can you use something more of the kind of a key value storage to actually?
Yeah, like that.
Mhm.
Like a yeah. But at every step, if we do that, the only reason I was trying to do that was at every step we have to see if all the values are true. So that would mean like if so that would be like m star n.
Right. So this is going to be the complexity if on every step we basically check
Check the whole
check the
macro.
core array, but maybe we can lower this down by being a bit by optimizing a bit, saying um,
Like use a bitmap or something.
no no um, although although this is like a good suggestion for lowering down the space complexity in terms of the time complexity. Um, so instead of checking the basically the dictionary every single time that we have
Mm-hmm.
the correct number of for each key, can we say
Uh-huh.
that by the time our key reaches a certain value, this changes a counter? Meaning, if we have stuff such as uh, say A, B, C, right?
Mm-hmm.
Right,
Mm-hmm.
input character array, and we have um, our dictionary such as like this. Yes.
Mm-hmm.
Is there a way where so let's say we iterate over it. When we find the character, we remove one, meaning we do a minus minus. When we leave a character behind, meaning when we like do something of the sort of this. So this way we like leave the B behind. We kind of single it out. We do a plus plus because now we need
Mm-hmm.
the character. Um,
Yeah.
can we use something like this, but choose one value and say if we actually reach this value means that it's a breaking point. Not a breaking point, but like the
A
border.
valid thing.
Yeah, the border. Basically, seeing it for the first time. To put it this
Mm.
way, we have unique characters. So, for instance, when you reach zero, you
Mm-hmm.
know that um, at the step where you reach the zero for C, you know that this is going to be counter plus plus, and this is going to be one value. Basically, this is going to be one of those. If those are the three check boxes you have, one checkbox is going to be checked, and when you have the number of check boxes equal to the size of the array, you basically have the solution, one solution, right?
Mm-hmm.
Yeah.
Yeah.
And going by this
Yeah.
methodology, can you actually
What about what I suggested initially though? Like you said, there's always one, right? So A, B, C,
mhm.
whatever. So next 25, 26, how many other characters? So basically what you said, exact same thing. So if you see B, it becomes 0.
Mhm.
And at every step, uh, you can just convert uh, binary to int of that array. And if it's 0, then it means it's valid.
Yeah, this is actually a really good optimization for space. Also, I'm gonna ask one question. Do you know what is the what case this is gonna work on? This is only gonna work on a subset of cases for the input. Do you know
Yeah,
what?
only if it's uh, there's no two B's. There's
Yeah.
only one B. Yeah, I think that we cleared in the beginning, that there's only one, there would never
Yeah,
be duplicates.
yeah. This is correct. Only when we have unique characters, this is gonna work. So,
Mm.
um, because we're analyzing the base case, and the base case is set to have characters such as A, A, B, B.
Mm.
Let's leave this for now. Actually, this is a bonus question which I had prepared as sort of like the last questions after we finish the implementation. So it's really
Mm-hmm.
it's good that you demonstrated this. But can we focus on like the base case, which is with these inputs and producing something to solve this for now?
Okay. Yeah, that sounds good. Um,
Can we just analyze the complexity that we're gonna follow for the solution that we agreed upon?
um, yeah, so we are trying to optimize not looking at the whole hash map, correct? At
Mm-hmm.
every step.
Yep.
So, um, so you want me to, I mean, if it's not, and we are trying to do it for repeating characters, correct?
Mm-hmm.
Okay, so there could be multiple. Um,
So yeah, it's still the same algorithm that you proposed, except
mhm.
that instead of instead of looking at the hash map at every step, meaning iterating through every key, we keep a variable and we do only one lookup on the hash map.
But okay, so let's say you're at a window, right? You CC and decrement to the value to 0. How do you know that the window is complete?
Well, so what would be the case in which what would we need to reach our counter to basically
So
have
all the values need to be 0. Oh, yeah, sorry, go ahead.
yeah, so we have a counter, right? And this
Mm.
counter equal the size of the array, right?
Counter equals size of the array.
Yeah, because
Mm.
like that's like all the special characters we need to find in. And if we basically the way we've set up the hash map is that if
Mm.
our if the key for our special character reaches 0, meaning that it's our needed iteration. And the reason we're picking 0 is because if we find like um, 4 Bs or like three
Mm.
Bs,
Mm.
this is gonna go 0, -1, -2, and we don't want to count after that because it's not gonna be valuable to us. So yeah, and the time we reach the first one for each character in the array, we have a solution, right?
Yeah. Gotcha. Um, okay. So the count of character matches. Yeah. Okay. So yeah, we have a count variable, and that should be the length of characters, special characters. Yeah. So if we do that, then it would just be we go of size of the input.
Hmm. And for space complexity,
So space would be so it would be like special characters.
hmm okay, um, let's go ahead and implement it then.
Mm, So I'm just going to start with like the basic case, I guess. Just making sure this. What happened here?
Yeah, don't worry about
Um,
syntax. Um, so yeah, I guess focus more on actually just writing out the code. Don't worry if it has some syntax errors. We won't be looking to immediately like run it or run it at all if we get ahead of time.
oh, okay, no worries. Okay. Um, uh, um, so I'm going to create start equals 0 and so I'm initializing the start. So when I try to like do this, I usually run stuff. Do you want me
Yeah.
to just
Okay.
write the
Sure.
code?
Sure. Then if it's easier for you, go ahead.
Um, so that would be the output. I'm going to just do this for now, and I'll change the counter because I'm not too clear. Um, Hmm. So I'm going to change the example here a little bit. Oh, length of the smallest. Okay, that works for the base case.
Mm-hmm.
So I'm just changing the input here.
Yeah,
Um,
yeah. Let's try with this.
so we are expecting, so the answer here should change. Okay, like that. Maybe ACB. Yeah. So that's the smallest window. I mean, it won't work now, but okay. Um, so after we see that, we have to move the start pointer
Mm-hmm.
forward. What I'm going to do is move the, um, so the window starts here from ACEB, like the first, comment this out. So the window here starts from AB, like the first valid character, maybe like that. Okay. So it starts with the first valid character. So I'm just going to move the start pointer to hmm, one more. Plus. So that would make the window invalid, but we also want to knock off like, so here if we knock off A, we also want to knock off till like B. Like we don't care about A, C, E characters. So
Can we do
move
it
the character.
while um, while our counter is valid? So I guess that would be while is valid, I guess. So you have a function, right? So while that function is correct, just continue the loop, I guess, because we
Okay.
want to
Uh,
when it's no longer valid, right? Because
Correct. But if we just remove, so for example, the window starts here A, C, E, B, yeah. Um, if we remove A, it'll say it's not valid, but we shouldn't have CE either in the beginning.
well, I mean, if we remove A, our basically our window stops and we start moving forward again. So we're gonna remove
But we,
CE. We're gonna move in CE regardless because um, by the by the idea of how the algorithm works, because we always find the most compressed value, the smallest value that we can find from a given substring, a valid substring. So it doesn't matter if we remove it immediately or in the next iteration, it's still gonna get removed.
okay. Um,
Let's try with that.
oh, what happened there? Oh, we need to increment the count to, uh, hmm,
Right. Okay. Let's call this the end for the code phase of the interview and go a bit into um the other part. So yeah, so judging by the implementation, so yeah, um you create a counts collection, which is your hash map. Um, you basically on this, so you move the start until we reach a valuable character, I presume. Is this what this is doing?
mhm, yeah,
Do
correct.
we really need to do that separately?
I guess we don't.
Mm-hmm.
I guess
Because
when once you find the valid, you can just remove the invalid from the beginning. We can move the start pointer. Yeah, we don't really need to do it. Yeah, you're right.
yeah, so I would say that the solution could take the form where this if is valid is just a while loop, and this while loop
Hmm.
only starts if it is valid, and of course you do everything related to finding if the substring is smaller than the one that you have, and then
Hmm.
like in the last character. But I, 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 just to check that if you've understood, so you're checking the brute force way currently for the is valid, but well,
Hmm.
how would you check with the counter? Meaning, if we have a counter variable.
So it would be, yeah, counter equals 0. and so I do that. So I increment the counter plus equals 1 here, and counter equals.
But over here, do we want to increase the counter in every single one that we find? Like if we just need A and B and we have like,
Oh
oops,
yeah, you're right.
this is
There's
interesting.
second A.
Yeah,
Yeah,
like this.
yeah, you're right. If so, yeah, there would be an if condition. Uh,
I mean, just you can just tell me what the if condition is, not to waste time to write it.
so if we're so if we found like two A's, yeah, two A's, um, and you already found A, so you would see like the counter value would be 0. So you did not actually find one more. So then you won't decrement the counter. I mean, increment the counter.
Right. So okay, yeah, because here, yeah, okay.
So you
Um,
make sure that you actually found
mhm.
it. Yeah.
How would this handle if we have? I mean, this is just more of a question. Like, w- would this and where would it break if we have the condition that our character array now can have multiple variables? Not multiple variables, but duplicate variables. Say our input character array would be a a a
Yeah,
b
sure.
c. Yeah, this is
Hmm.
valid.
Yeah. So you mean how would this break if for the specific counter increment or in general?
No, I mean, your solution, like how would it handle this new input?
So it should yeah, it should still work. It shouldn't matter to the solutions. It's agnostic to the actual counts.
Mm-hmm. Okay.
So it should not matter. Yeah, it should still work. It's not making an assumption that there's only one.
Mm-hmm. Okay, yeah, and my other question would have been about the bit array, but you pointed it out in the beginning, so I'm gonna end the questions now, and I'm gonna go into the feedback phase. So
Okay.
generally, I would say that this was a good interview. I would now I will give a pass. So if you haven't done an interview here, it's basically there's a checkbox where it says pass or no pass, and then the other stuff
Mm.
are just description. So yeah, because you basically even though we had some issues here, like until like the time ended, you hadn't completed this part, so I guess we went a bit over time, but in a real interview, like they would be pretty strict in saying 35th minute or 40th minute, the one they've agreed at the beginning. This is like the end. Yeah, could you stop writing? But even going from there, like you implemented the bulk of this. Um, I would say you could practice a bit more, just on the first part where like pinpointing the solution, because judging that you will manage to implement it, and then like when I gave you a hint, you understood what I was talking about. You basically know how to solve it, but practice a bit. I would say pattern matching a concept, a programming, not a
Mm.
programming concept, but a problem concept to a given a given text or a given problem, because as you know problems can vary a lot. Um,
Hmm.
I'm just gonna paste some links which might be helpful. So this is the window sliding technique. So I guess what they call it then, for doing doing the basically sliding window approach.
Yeah.
And I'm gonna give you a bunch of questions relating to that. Well, like a bank of questions relating to that. Let me just find the link, which you can practice on, of course. It's on the same website. Yeah. So I think like 200 questions just on the same concept. Of course, they're not all the same. They're just like tossing around different stuff around this concept. Other stuff that I
Uh-huh.
would comment on, I would say it would be very good if, like, while coding, you just say, well, just lay out your thought process while coding. don't let like the interview go into a bit into silence. Of course, this is not just
Yeah.
your part. The interviewer like shouldn't be someone who just like stays silent the whole interview. But while you're coding, aim to actually like give out your thought process, because if you don't say anything, I'm not gonna like start asking until you finish, because I don't want to like get in between and like ask about every line. But by giving out your thought process while you're writing, if you have some wrong assumption or you're going the wrong way, the interviewer can just say, "Oh, wait, what you just said? Let's backtrack on that," or starts asking questions more or less. Um, so yeah, I guess this is one thing, and the other one is about the. I saw that you rely on the compiler. Well, not rely, but you like using the compiler. So keep in mind that not in
Mm.
every interview you're gonna be giving you're gonna be given in a compilable environment. A lot of the
Yeah.
interviews that I think I've done is just a flat out like document of they just like you have a link to a document which you and the interviewer have access to, and they just paste something on a doc file, and it doesn't have any of that. So I guess uh, focus at the beginning, focus more with implementing to just like lay out your logic in code, and then if they ask, well, let's actually compile that, then start thinking about syntax. And um, I guess it's more on the side of don't rely on the syntax and the running to check your logic, because it might not
Of
always
course.
be available. But
Yeah.
I guess those are just my 3 points. To practice more a bit like the first part, which is like just labeling questions based on the text given. Communication a bit more while you're coding, and you basically ask some clarifying questions, which is good. It's always good to ask clarifying questions. So the more you ask, the better. I really like that you gave this. So when you have ideas such as those, always put them up, because, for instance, this one was I was supposed to give it as a bonus question, but the idea that you thought of it before I actually asked about it and is a plus. And yeah, the third one is just don't rely so much on the environment. And yeah,
Hello. Okay. Yeah. Yeah. That's really good feedback. Yeah. Yeah. I can see lots of errors. Yeah. It's been a while since I did sliding windows, so it's just not fresh off my mind. But yeah. I agree with. I was really quiet too when I was writing code, and yeah, relying on the compiler. Yeah, that was really good feedback.
okay. Thanks a lot for the time for this interview. Hope it was useful. It was useful for me, and I'm gonna wish you a good day.
Yeah, same to you, man. That was really useful to me. Yeah, really good feedback. Thank you so much.
Thank you. Bye.
Thanks. Bye.